Muchas gracias por estar aquí. Yo soy brasileño, soy portuñol, pobrecito. Very well. Esta charla es en inglés, pero el material es en español. So, if you don't speak English, you can try to go along with the material, and I'll try to use my killer Spanish once in a while here. So this charla is about resource management, Kubernetes resource management, desmistificando la gestión de recursos en Kubernetes. Everything that you like to ask, but we're afraid to ask. My name is Rafael Brito. I am a principal engineer by Stormforge. We were recently acquired by Cloudboat, which is a proud silver sponsor of this event. Just a quick background about me. kubectl get Brito Rafa. I'm old. I started my career in the 90s with Novell Nature and Unix HPUX. Does anyone ever work with Unix? Oh, there you go. That way. In Brazilian, brasileiro, we say tamo junto. We are in together. It's a good slang to have if you're ever going to in Brazil. Tamo junto. I was born and raised in Rio, but I spent most of my adulthood in the United States. I used to live in New York for 13 years. Now I live in Austin, Texas. Basicamente, sou gringuito. My first Kubernetes cluster in production was 2016. I used to run all the Kubernetes for Citigroup between 16 and 19. Very proud to see that we were the first American financial company using Kubernetes in production. Then I moved to VMware. And before VMware, I used to work for New York Stock Exchange, the Bolsa de Valores in Nova York. Right now, I'm a principal engineer by Stormforge. When I left the bank, I had this mission to make Kubernetes easier for enterprise. And one of the aspects I'm trying every day to solve is better resource management on Kubernetes, and we do machine learning. I wrote the controllers that run on the clusters for our customers. Very active to the community. I organized the CNCF Austin. This year I organized KCD Brazil. I organized KCD Texas. I'm getting tired as we speak. It's a lot of work. And right now I am the TAG Operation Resilient Co-Chair by CNCF. And me and Chad, we wrote this book. I forgot to take out of my, sorry about that, the improvisation. So we wrote this book. It's going to be out in a couple months, but there is in digital format. And we're going to give, thank you. It is being a lot of work. You have no idea. And there's no money on it. It's just for the love. And we're going to give 6 books. By the end of today, we have gonna show a QR code. I don't have it, but you put your name, email, and we're gonna give away 6 books. All right, let's jump in it. Why do we need to care about management of resources in Kubernetes? ¿Por qué debería preocuparme? Well, there are major 3 things, among a lot of things, 3 things. One is reduce the problems with performance and reliability. When you don't give the resources that each workload requires, you're going to have problems, outages, latency, and so on. The second, and I'm very keen about it, many people go to Kubernetes thinking that you're going to save green dollars. Not necessarily. Actually, I have a slide, 50% of people see their cloud bill go up. Of course, you got other ways to get this money back, but green dollars, the one that comes out of your checking account. And the third is when you have big clusters, have multi-tenancy, when you have correct management of resources, you reduce the noise. And of course, you reduce all the manual labor that you have to do to put up those fires. Right, let's start to get a little engineering geeky here. The most primitive, the two primitives for Kubernetes, requests and limits. The way that I like to explain, it took me a while to get those. They seem simple, but when you start to dig, you see that's not that simple. So request is the minimum you give to the container and the workload. Limits is the maximum. Very well. When you set requests in one value and the limits higher, you give this option for the request to be burstable. I mean, to the workload to be burstable. Very simple so far, I guess. Let's go a little bit deeper. What does it mean? What's the relationship of requests with the Linux kernel? What if I tell you that Linux kernel, by the way, sometimes I say bad words, so bear in me, I'm apologizing in advance. Because I usually say, the Linux kernel does not give a shit about millicores. It's not such a thing. It's all about time, And time means shares of time of the CPU. So in this example, this slide is a little bit busy, but it shows a 2-core node. Half of it has been allocated to workloads, another half not yet allocated. So you define those millicores. In this case, you have Nginx 1, 125, Nginx 2, 125, the other one 5. By the end of the day, they are shares of time. And they are proportional for the entire box. So if I run right now a workload in this machine that has half of the workload, the resource not allocated, the other ones will take more CPU if they need. This is just to show the abstraction that Kubernetes give to you. It's much simpler to think in millicores than in shares, than in time, and etc. That's one of the reasons I love Kubernetes. Now, the kubelet runs on the node. And it is responsible to manage that resource. It's managed to convert that abstraction from millicores to share. Uses cAdvisor. It's embedded into kubelet, a piece of software called cAdvisor for metrics. And define something very important, which is called quality of service. So you have pretty much 3 types of quality of service. Best effort, when you do not set requests and limits. Don't do this, please. And I have a couple of slides about it. Burstable, when you have requests less than limits, that means that it can go up. And guaranteed, when every container of the pod has the same value of CPU and memory across requests and limits. And why those QoSs are important. I have a couple demos showing how kubelet and the operating system work when they are under pressure, under resource pressure. Right, gonna go for first demo. Alguém aqui esteve em uma charla ano passado em Medellín? 1, 2, okay. I'm gonna ask a couple questions. If you know the answer, don't answer. Okay? All right. So the demo is showing how requests and limits are important when it comes on competition of resources on the node. So the first video, I'm just gonna set up my environment. Basically, my environment, I have one node, one worker node, okay? It's I'm going to show it has 2 cores and 2 gigs of RAM. And I'm showing here the capacity and allocatable. Very important metrics to know. There are 4 metrics that I absolutely love in Kubernetes. Capacity is the physical aspect of the node. Second is allocatable. It's pretty much the capacity minus what Kubernetes is asking to run, because Kubernetes is very important. It's a systemd process and needs resource. After that, it's everything for grabs. It's allocatable, very important. So basically here I have 1.8 gigs right here in the bottom, and I still have 2 CPUs to give for my workloads. Okay, continue on. I'm running kubectl top, another favorite of mine. Basically, this node is only using 5% of CPU and 52% of memory. This is reutilization of the node. You have to understand that utilization is different from allocatable and allocated. They're different. What you want is high utilization matching with allocated. That's when you make most of your money, most of your pesos. Now, I'm going to run 3 workloads. Okay? I have all this on the QR code. It's all this code is open. All this demo is open. Basically, I'm running 3 workloads exactly the same. They are the software that Kubernetes uses to test itself. Basically, you inject how much CPU you want to use. I have C1, C2, C3. C1, there's no request, no limits. Basically, it's best effort. C2 has requests, but no limits. And C3 has requests and limits. I'm going to show the QoS. Now they're running. It's just going to show again what kind of QoS I'm running and which is the request. You got to remember this node has 2 CPUs and 2 gigs. So C1 didn't ask anything, best effort. You know, run for the hills, whatever you can. Second, I'm requesting half CPU, 500 millicores. And the C3 has a request for 500 millicores in a limit of 1. I'm putting a limit on C3. Very well. This is my setup. Now the fun is going to start. I'm going to inject to each workload, hey, use 550 millicores. This is the software that we are using. Basically, you can tell, you inject, hey, use CPU. And right now, I have this Grafana board. I'm showing here my baseline. I have those 3 running in parallel, and each one taking 450 millicores of CPU. Okay, now, the importance of having, not this one, that's my code. Requests and limits. So I have my 3 workloads running all together, all nice. But then real world happened. One of them, the one that requests and no limits. I want the entire CPU of this machine, the 2 cores. I want to grab it all. Question number 1 for everybody. What is going to happen? One of them wants the entire CPU of the machine. Stephanie. Which one is going to be out? C1, C2, C3. C1, there's no requests and limits. C2 has requests and no limits. That's the one. No, she got it.
But wouldn't it average out at the end because it would have a total assigned of 2,900. So most of it would go to the no, request no limits, but the other ones would still have some scheduling or not at all.
I'll show you.
Maybe if you try to restart the pods. Yeah.
Well, the pods just happen to be running. Look at what happened. Look at what happened. So this is the one, no limits. I want the entire CPU of the machine. The green didn't have any requests. Like Stephanie said, it's starving from CPU. The yellow that get requests and limits, 500 requests, said, dude, I have requests. Fuck you. I gonna keep my CPU. You try, but who suffered? The one without requests. Now, this is just a demo. Imagine this happening in milliseconds, right? Gotta remember, cAdvisor only takes samples of 10 seconds per time. If you scrape cAdvisor, you're only gonna have 10 seconds granularity, tops if you're lucky. So this is just to show how behind the scenes is happening. Because this guy does not have Linux CFS, when this one starts to grab more CPU and there's no limits, the Linux kernel gave to him, and this guy hold the Terran. This is mine, you're not gonna take it, okay? I have another demo about this guy that has a limit trying to take over the entire CPU, but you see this throttling and so on. I'm not gonna go to this demo right now. Right, let's go back to the whole point is the importance of requests. The importance of requests. Set something, but don't neglect the requests. So we StormForge, we go to many customers. Basically, that's what we see, that's what we recommend. There's pros and cons about CPU limits. But the end of the story is they are important. Limits are important when your requests are not well tuned. And limits are important for memory. So CPU, what it's called non-compressed resource. It's kind of like expand and so on. Memory has a limit. It's finite. It's finito. So you have to put a limit for memory. Now, the scheduler, Kubernetes scheduler. How Kubernetes scheduler assign pods to nodes. Sometimes Spanish come out. That's a myth that the scheduler look at limits. Scheduler does not give a shit about limits. It's all about requests. Okay? Now, there's one thing. If you go to a pod and set only limits, not requests, only limits, the API gonna go ahead and set requests to the same value of limits. That's why it's the confusing part. But the point being is it's about requests, not about limits. It kind of check all the nodes if there is a space, because it looks like how much you want. How much is your request? Oh, 200 millicores and 1 gig of memory. The scheduler goes to all nodes and see which one has a space to allocate that guy. It's kind of beauty. The problem is, depending, you can configure the algorithm, put more in one node that has a lot. The default is least allocated, gonna look for nodes that are empty. Money-wise, you end up having a lot of nodes with like a little bit empty. Sometimes you wanna compress more. But that's the life of the scheduler. Now, That's another question. How the scheduler will find place for pods that do not have requests, because it looks for the request to find a node. That's another cool exercise. Create a pod asking for 10 cores, but your nodes only have 8 cores. What's going to happen? Those pods will never get scheduled anywhere. That's how schedulers are dependent of the requests. Now, if you don't have requests, what the scheduler gonna do? You know, I'll give a book if you know. Just try.
Send it to the one with least
Good try.
request.
Good try, but no. Okay. For the sake of time, when you do not know what you do, you ask ChatGPT, right? ChatGPT 5, the best model ever. So I ask, hey, ChatGPT, are hard-coded values on a scheduler with pods without requests? After 30 seconds, no. This is wrong. There are constants inside of Kubernetes scheduler code for this. After almost 3 minutes, ChatGPT, you're right to push this, but there's no constants. Okay, ChatGPT, I'm not losing my mind because I've been talking about this for 3 years. So I dig the code again, and I said, here's the line. And ChatGPT said, 1 minute. Yeah, you're right. You're fucking right. Look at this. If you don't set your pods with requests, the scheduler gonna assume you need 100 millicores. And even worse in memory, it will assume that you need 200 megabytes. What if you're running something that needs more than 200 megabytes? This is the segue of the second part. When nodes are under pressure. When nodes are under pressure, need to expulsion. I'm killing my Spanish. Expulsion and eviction. The kubelet will detect I'm running out of memory. Now, there's 2 types, and people confound this very much. When kubelet is enough to know that I'm running out of resources, it will make an API call to evict the pod. And guess which pod gonna go first? The best effort one. The ones that you did not set in requests and limits. If you walk away one message, that crazy dude, the Brazilian gringo, said, I need to set up a request and limits. Requests only, limits only if you get shitty requests. But to set, that's what's gonna happen. Now imagine you have a database, you didn't set any requests, the scheduler gonna assume you need 200 megs, but in reality you need like 2 gigs. That's the first one to go. Now, there's another misconception, not a myth. My grandmother said to me once, don't ever believe what internet tells you. Not even ChatGPT, right? So this guy wrote a blog on Medium once, telling that pod is evicted by pressure the node on CPU. They say, no, dude, your graph are awesome. Not shaming anyone here, but just show that this topic is very confusing. There's no eviction because of CPU. If there is competition for CPU, happens what I show you in the other demo. Now, there's a second situation where even your exhaust of memory, kubelet will not even detect this. The operating system will, the Linux kernel will, and Linux kernel will do a killer on the pod. It's different from eviction. This is when the operating system is in a completely shit show for memory. So it will kill, And with will kill, it's not deterministic what it will kill, but probably it's going to be best effort, because when you have best effort, the kubelet sets the accord ADJ. It's a score for to prioritize those. How much I have? How much time I have? 10 minutes?
Officially,
Now?
0 seconds.
0 seconds.
Officially, but you know, we all started a little bit late, so I would say maybe a couple extra minutes. Yeah.
5 minutes? All right.
Sound good? Yeah.
Gotta be careful because I'm from Brazil. We don't have a concept of being on time.
I don't either. You want me to set an alarm for you?
Great. Give me
2-minute warning?
give me 5 minutes in total and 2-minute warning. I will show quickly the demo of eviction. Eviction? No. Let's do first. Basically, in this setup, I have three same workloads. One has requests, limits, other one has only requests, another one has no requests and limits. So basically, that's the same node, same amount of node. I ran by kubectl top nodes, one of my favorite commands ever. So right now, my node is using, is not allocated, not allocatable, is usage. I'm using 1.4 gigs of this node and have 3 workloads running, and this is my capacity. So I have more or less 19% of memory on this node. Then I go ahead and tell one of the workloads, hey, grab more memory. You grab more memory. Pretty much the same as the other demo, but this one is memory. What happened is the operating system gonna freak out, not kubelet, because it was a big spike of memory. All of a sudden, poof, the operating system kicks first, and the one with no requests and limits, come on, no requests and limits, will be terminated. It's a event, okay? If I go kubectl get events it's an operating system event. It's not a kubelet eviction, okay? Right, for the interest of time, finishing here. I have, if you guys want to talk about the new in-place pod resizing, it's a new, how to adjust this real-time on pods, more than happy to talk. I have a blog about it. There's a lot of gotchas that I did for it. But here's my hot take in the end. If you really want hot fix pods, you need a strategy for patching. I declare that you have to have patching for workloads, patching for pods working together, and you need a strategy. You pretty much want, during the production hours, you want to increase your resources, and then after hours, you just patch your deployment. So requests, very important. Limits, not that important. It's important for memory just to make sure we don't have a memory leak, etc. But limits are important only when your requests are shitty. Now, that's the elephant in the room, in my opinion, for Kubernetes. Who sets the requests? App team or platform team? I call it when a dog has 2 owners, is starved to death. How to say this in Spanish? En la perro ten dos dueños, morre de hambre. I'm killing my Spanish. And that's what we see in the day 2 from many customers. Nobody cares to set those. You start to get problems. Then you start to get with one value, good for all, continue with the problem. And then you start to configure one by one manually, and you cannot scale. I was there as a platform engineer manager at Citigroup. I had 500 apps. I only gave attention for the most important apps. For the other ones, it's on your own. That's my company. We give requests and limits calculated by machine learning. I have a lot of cases. If you want to talk to me, I'm more than happy. And that's it. Thank you so much.